this video we'll be going over the C# video tutorials for csharp.net. So we'll be continuing with the we'll be talking about objects and classes and objects. So these are just a quick run through notes. So we'll be doing some more code examples soon. So we'll just have some notes down here. So we have passing an object to a method. So objects of a class can be used as a parameter of a method. So for example, we could have private void, we could say show coin. So we could, if you remember if you've seen the C# playlist on this channel for the Code Invest channel, you can, if you haven't seen the video, you can just check out the C# playlist. So you can check out the last video where we made a class and then we kind of created and instantiated some objects for it. We made a separate class aside from the form, so we created another file. So I've deleted that one, but we can just pretend we still have that. So we can say that this method takes a coin object as a parameter. So just like that. That's all you need to do to take an object as a basically as a parameter. You just need to pass the object type in the parameter, pretty much just where the parameters go, just pass it in. I believe you can just name it anything. Then here, for example, we could have a message box.show, and we could just say that the current side is, so we could have a string and then concatenate it. Then we could say that we want to call coin, and then another method that we had. So that's just how to pass a parameter, pass an object parameter, like that. And then when you want to call this method, for example, you could say that you have a coin points to new coin object. Then here you could say that you want to call show coin and then pass in coin, like that. So this is a pass as an argument. To pass an object as an argument. Pass an object as an argument. Whoops. So in this example, a method named show coin accepts a coin object as an argument. So to create, or as a parameter, basically. It takes a parameter and accepts an argument. So to create a coin object and pass it as an argument to the show coin method. So for example, you could just instantiate an object here and just pass it in as we did. Okay, so these are just quick run through notes. We'll be continuing these later on with some examples, some labs and examples too. So now we have properties. So properties are pretty much special in C#. I believe JavaFX has them, and C# has some. So they're more so for like GUI languages such as .net. So not just C#, but like the framework .net has them. I'm not sure if C# alone has them, because usually you don't really use C# for non-.net apps. I mean, you might, but in most cases you'd probably use another language. So in this case we just have, so basically just to start, so a property is a class member that holds a piece of data about an object. So let's just write that down here. Sorry, I have some cream on my hand. Had to wipe it off. Okay, so we have like lotion. My skin gets dry occasionally, so I just had some lotion on my hand. Okay, so we have a property is a class member that holds a piece of data about an object. I spelled piece wrong. I before E, except after C. Okay, I before E, except after C. Get confused about that one. When you stop writing essays, you'll know once you get to third year and fourth year, or even way past that because I'm late. But once you get to third year and fourth year university, you'll be like, even after first year, usually in a computer science major, you won't be writing essays again after first year. Usually you just have first semester English and second semester English. I guarantee you by the time you get to third year, you'll forget how to start spelling words. You'll forget how easy words are spelled. Basically, once you finish your electives too, which I already did. So anyway, so here we just have a property is a class member that holds a piece of data about an object. So property, it's basically a special, I believe it's a special method, but we'll be discussing that coming up. So it's a class member that holds a special piece of data about an object. Properties can be implemented as special methods. Okay, yeah, so they are special methods. That's what I remember the doc saying. The properties can be implemented as special methods that set and get the value of corresponding fields. So they're not necessarily setters and getters like normal, like pretty much like conventional, which is like the convention in most languages. You can even right click somewhere in like a lot of IDEs and they'll generate getters and setters for you. It's not talking about that, it's like something else. So in this code there is a private field which is known as a backing field. Or sorry, in the code there is a private field known as the backing field. So there is a private field which is known as the backing field, and it is used to hold any data assigned to the property. So the value parameter of the set accessor is automatically created by the compiler, so it's a little tricky. So let's just see, is there a little bit of a code example here? I've seen these before. Okay, so I'll just try to explain what this is. It's going to be a little confusing. Well, let's just pretend we have a class here, so let's just go with example 2. I don't even think I can really write these in. We'll just do it in the notes. I was going to think maybe we could just create an extra class, but we don't really have another class to use it with, so we'll just pretend we have a class here. So this should be lowercase. So we have like a pet class or whatever. We go with like a cat class or something, whatever. So like this, we can pretend that we have a private string name. So this is the backing field, so it's kind of confusing. We'll be discussing this coming up. That's the backing field, and then the constructor has, for example, public, so we call the class name to reference the constructor. Then here we just say, oh sorry, it's like this. So you go underscore name points to an empty string. We go public string name. So I think this is pretty much it right here. So it's a little tricky. We haven't really used them. Don't worry if we do. We should be using them coming up to explain this example. Otherwise, don't worry about it. So we should be having some kind of lab coming up with it. So these are just my professor's notes, so we'll just kind of just write them in here. So we have, for example, get, well, this should be in a little bit. Then we'll go return name like that. That's your kind of standard getter, but it doesn't work exactly the same. As you can see, the syntax is a bit different. So for example, we could go underscore name. Name here should have a underscore here. Underscore name points to value. Okay. So yeah, something like that. So don't worry about it. We'll be talking about that coming up. Okay, so we can set the we can set a cat object's name property, for example, to something. So we have a name. So we're basically just getting it and setting it. So we could set the name to something later on. So we'll just talk a bit more about pretty much about the backing field. So the private backing field is a variable that stores a value assigned to the property which the backing field is associated with. It is declared to be private to protect it from accidental corruption. If a backing field is public, it can then be accessible directly by code outside the class without the need for accessors. Okay, so you use accessors, pretty much getters and setters, to change your private fields. I've seen that like in other languages before, so pretty much you can do that. You can create a method for a private field. For example, this is private, and you can use getters and setters to set it outside the class. So the get versus set methods, the get method is not empty. The get method, if not empty, is a method that returns the property's value because it has a return statement, so it's just like your classic getter. It is executed when the property is read. The set method, if not empty, gets the value stored in the backing field and assigns the value to the property. It has an implicit parameter named value. It is executed whenever a value is assigned to the property. Okay, so read-only properties. A read-only property can be read, but it cannot be modified. To set a read-only property, simply do not write a set method for the property. So that just means you just have a getter. Okay, so okay, so this is our class here. So this is pretty much, so let's do another example. So what it would be like is, so for example, let's say we have public double diameter or whatever, or I don't know, that's fine. Diameter, so we go open a block. So they did it like this, but you don't have to do that. Whoops. I've seen it done like this before. So notice how these don't have any parentheses on them. That's kind of the so it's kind of like, it's pretty much okay, so it's pretty much, I think the backing field has the underscore in it. It's a little tricky. Don't worry, I don't think my professor notes are that great. I'll try to explain them, but if you're still confused, don't worry, we're going to be going off another set of docs to explain this better after the quick run through notes that I've been doing for a while. So pretty much we just have public double diameter, So you can do it like that, or you can do it on the same line, which I don't like. I've seen that happen before in other languages too. Like they do methods like that sometimes. Okay, so here we just go return underscore diameter set, which you wouldn't have if you want it to be a read-only property. In this case, to make it read-only, you wouldn't have the setter, which should make sense. So this is the same thing, public double diameter. So instead of having our setter as well, we just have our get and then return underscore diameter, like that. So we don't include the setter for read-only. For read-only properties. Whoops. Okay, so auto properties. Sometimes a property simply gets and sets the value of a backing field without performing any other operation. So auto properties simplify the code for such a property. Example. Okay. So it kind of auto sets everything and gets it automatically. So that would be something like this. Let's go with example 4 here. So we'll have, for example, public string name. Why is that capital? Okay, so public string name here, we just go get like that and set like that. So that just sets it automatically. I believe .NET can do that. So if here, for example, what we could have is equivalent to private string underscore name. So this is our getters and setters here. To here we have get, then we just do the same thing, return name. So it's not that hard to remember how that you just have to get and set them. I think the theory behind it is more tricky. Like where do you use it and all that, which we'll be discussing coming up. So don't worry about that. So just kind of remember what the syntax is, how to set them up. You just kind of open up your variable like that with an underscore and then just get and set it. You just get and set it like that. So with auto properties, a hidden backing field is automatically created as well as the code for the get and set methods. So in fact, most programmers prefer to write an even shorter version of the property like this. So you can write, for example, a string name property like this. Actually, I think even you could go is the same as also this, which is you could just go public string name, and they write it like this, which I don't. Usually I would just go with this one at least. Get and set, which is pretty much the same thing. They just open the block and do it on the same line. It's up to you. It doesn't really matter. So you can initialize an auto property like this as well. So you can go public string name. Get, set, close that, points to, I don't know, you can just go like that. That's the name. So Teague is a name, so you could set up the name property like that. Basically initialize an auto property. So read-only auto properties, if you leave out the set keyword in an auto property, the property becomes read-only. So we already talked about that earlier on. Okay, so finishing properties, we'll get back to that. we'll be doing we'll be getting back into properties, and actually I know they're a little bit tricky, so we'll be actually doing some actual code examples with like running them and stuff like that. Like normal coding with some actual code execution. We'll see how the apps work with them and all that. So we should have those coming up. That'll be also in the playlist, so that's just some introduction to them. Just an introduction to properties and parameter passing, object parameter passing. Okay, so the third thing that we have here is parameterized constructor and overloading. So you may have heard me say that some things are overloaded. Methods are overloaded, so that just means the method can take more than one parameter. So it has multiple definitions. So a constructor that accepts arguments is known as a parameterized constructor. So I don't think we've done these too much. So we can just talk about that a bit. So a constructor that accepts arguments is known as parameterized constructors. So for example, we could have a public account. We could say that it takes a decimal balance like that. So you could say that our account class, for example, when you instantiate an object, it's going to take, it takes, for example, a parameter. So we'll show some examples of that definitely in the example in the code in the labs coming up. So a class can have multiple versions of the same method known as overloaded methods. So known as overloaded methods. So how does the compiler know which method to call? Well, it was basically it relies on the signature, which is basically the parameters that you pass. So binding relies on the signature of a method, which consists of the method's name, the data type, and the argument kind of the method's parameter. So it also goes by type of parameter as well. So for example, you could have that, so back, if that would go to the, okay, so it is, so see how we have public account up there, it takes a decimal balance. You could also have public account, which takes a double balance. So basically you can have the same variable but with a different type, or you could have a different variable with a different type altogether, or another. I believe you could have two of the same types but different variable. So the process of matching a method call with the correct method is known as binding. Remember that being a multiple choice question, so the process of matching a method call with the correct method is known as binding. So I've seen that on university tests as well in other languages. So the process of matching a method call with the correct method, usually in regards to overloaded methods, then it's known as binding. So it's exactly the same thing as Java. Okay, so overloaded methods, when a method is overloaded, it means that multiple methods in the same class have the same name but use different types of parameters, sometimes a different amount of parameters. So like we've seen that before, like one method, for example, like the deposit method, it could have one parameter, two parameters, three parameters, four parameters, different types, and the same type, or all that. It could have, if basically they all can be different. So overloaded methods, so for example we could have like a public void deposit method. We could say that this takes a decimal amount, whereas here we could say that we have a public void deposit method, which takes a, for example, double amount. We could have another overloaded method, public void deposit, that for example takes another parameter which is an int, which we'll call it numbers. We could have another one, we could say that we have a public void deposit method that takes a string, str or something. So you should be able to add more than one parameter to it, obviously, different types. So that all gets taken into account of the method signature and helps it with, well, basically leads to the compiler overloading them with its binding signature at runtime. So that's how it differentiates between them. So if we haven't talked about this, so constructors are special types of methods. I know we already said that for properties, but if you've done other object-oriented programming languages, that's the same definition. Didn't we just do this here? Okay. I think I had a constructor that accepts arguments is known as parameterized constructors. Okay, we glanced over it, so now let's actually go back to constructors then. Constructors are special types of methods. They also can be overloaded. So for example, we have this, for example, the public account example again. So this is the parameterless constructor. And then for example, we could overload that. So we could say we have an account. Spelled it wrong the first time. Okay, so account. We could say that it takes different parameters here. We could say that this one takes a decimal balance. And here we can overload that, and then here we could say, for example, that we have another one that takes a, for example, double balance, so it takes a different type. So that means it can be overloaded. So the compiler will find matching constructors, so we can just skip over that. So that just might be it for the first part of the notes. We still have a little bit more to store class type objects in arrays and lists. So it's pretty much the same thing as storing struct objects. It's probably easier than that. So this stuff isn't too hard. I'm going to try to go over the properties, which I might have confused a little bit. I don't think I explained it that well. So we'll be doing the properties, more discussion about the properties coming up, not in the next video, but within the next few videos. So if you're interested in that, do check out the playlist, the C# playlist on my channel, csharp.net. So in the next video, we'll be continuing with storing class type objects in arrays and lists. So thanks for watching, guys. If you guys like the video, you can like and subscribe to support the channel for more programming and investing tutorials. In the next video, so we'll be working with more objects, arrays, and lists. So thanks for watching. I'll see you guys in the next one. Take care. Thanks.